Hello, this is Chris. I'm with Learn with Orm Math Help, and today we're going to be learning about factoring trinomials in the form ax squared plus bx plus c equals 0, finding what x value could possibly make this equation true. Factoring is a topic that is hated in all of algebra. No matter what branch of algebra, anywhere from 6th grade all the way up through college, everyone hates to factor, and with good reason in my opinion. It's one of those topics, and it's especially one of those topics that you have to know in early math that doesn't have a set step of directions on how to definitely get an answer. Because sometimes there is no answer. That's even a worse point to make. There are ways to manipulate trinomials such that it can help you try to factor. There's patterns to see, but there's no direct step on, well, I know how to do it, so I'm going to get an answer. And a lot of people hate that. The only way, even in higher mathematics, there's no, oh, well, we learned how to factor this way back in high school or whatever, and now we can learn a definite way of factoring. No, there is no way. It's all about trial and error. So let's go ahead and start with a simple equation. Let's say 4x minus 8 equals 0. Now, this is an easy equation. You can just add 8 to both sides. You can get that 4x equals 8 and x equals 2. X equals 2 is the only solution to this equation that makes it true. We can plug 2 back into here and get that 4 times 2. What? 4 times 2 minus 8 equals 0. And that's 8 minus 8 equals 0, and that's a true statement. 2 is a valid solution. But what if I were to add an extra x? What if I were to have, for example, x squared minus 3x equals 0? There's no real way you can just manipulate this around to see that, well, x can be this, and that is true. But one thing that we can do is a thing called factoring. And what factoring is it's taking certain, it's like, okay, I'm sure you've seen the distributive property, distributing things out. Let's go to a different color for this. Let's say we have the expression 3 times x plus 2. Now you know that you can multiply this by this and then this by this, and this is also, it's the same thing as 3x plus 6. I'm sure you know this. This is a true statement. This is a valid operation, I mean. But what if you started with this and you wanted to go backwards? Let's say you wanted to factor. Well, you can factor a 3 out of this, and you'll end up with 3 times 3x divided by 3, that's x, and what's 6 divided by 3, that's 2 plus 2. And that's what factoring is. You're factoring a 3 out. So remember that you can write x squared, if I can go back to this, as x times x minus 3 times x equals 0. Now, they share a common factor of x. You can factor that x out, and what you're left with is x times, what's wrong with me today? X times x minus 3 equals 0. And then you can easily see that, well, okay, you're multiplying two things together here, multiplying x times x minus 3. Now, 0 times any number is 0, right? Yeah, that's a true statement. So when x is 0, you see that 0 times something equals 0, and that's true. X equals 0 is a valid solution to this problem. Now, when this expression is also 0, or when this expression is 0, then that's also a valid solution. So we can set this equal to 0, just this little expression here, and find that x equals 3. It's also a valid solution to this up here. Both these solutions are correct. So the way we write that is x equals 0, comma 3. Either of these numbers, when put in for x, satisfies this equation. Alright. Now I hope, since you're talking about factoring, you've been exposed at least a little bit to foiling, kind of like distributing out two multiplying out multiplying out polynomials. For example, when you're multiplying out, if you're given x minus 2 times x plus 3, you know how to FOIL. That's first, and then what is it? Outer times inner, and then last. It's a face, right? Yeah, it's a face. Okay, sorry. And when you multiply all that out, you get x squared plus 3x. That's the outer. The inner is minus 2x, and then minus 6. That's the last term. Of course, you can combine these like terms, and this just equals, or gives you, x squared plus x minus 6. But what happens, can we factor this, for example, to give us this up here? Turns out, yes, we can, and there's a set number, there's a couple ways to go about that. So let's go ahead and try. Given x squared plus x minus 6 equals 0, find solutions to x that satisfy this equation. Now we know we're going to have two polynomials multiplied together. And we can see that, first of all, we can see that the first terms multiplied together is just going to be x squared. And the only thing that can give us x squared are x and x. So that's good. So now we need to find the best way to go about finding these last terms, and whatever, if it's plus or minus right here, is to look at this last term, because it's just those two terms multiplied together, right? Yeah. So what numbers multiplied together will give you negative 6? You have 6, negative 1, negative 6, 1, 2, negative 3, and negative 2, 3. And now since they're just multiplying by the 1 here, all you have to find is, when you add up these two numbers, something that gives you a plus 1x. So add these up, you get 5, add these up, you get negative 5, add these up, you get negative 1, add these up, you get 1. Hey, you get 1. Those two are probably the ones that we got to use. So minus 2 and then plus 3. And hey, look, that's exactly what we would expect. Minus 2 and plus 3. Alright, so we're on the right track. Let's do this again. Let's do another example, just to, kind of solidify this in people's minds. Let's use orange. Let's say we're given x squared plus 4x plus 4 equals 0. What solutions, what numbers for x are valid solutions to this equation? Well, same kind of thing. Let's do exactly what we did before. We know that this first term is just x squared, so the only things that can give us x squared are x and x. What give us positive 4 when multiplied together? Well, that's 4, 1, 1, 4, 2, oops, negative 1, negative 4, negative 2, negative 2, and 2, 2. Remember that negative times a negative does give you a positive. Again, we're just multiplying by a 1 here on both these, so you don't have to worry about multiplying them out, multiplying these by these to give us a middle term yet. So let's just add these together. This is 5, it's not 4, no. This is negative 5. This is negative 4. And this is 4. Oops. Hey look, 4 is what we're looking for. So this must be plus 2 and plus 2. Which, by the way, can be simplified just as something to note as x plus 2 squared, since you're just multiplying something by itself. That's just squaring it. So the only valid solution, we take this in here and set it equal to 0. So x equals negative 2. That is our only valid solution for this equation right here.